On the morning of August 22nd, 1986, a local doctor was riding his bike toward the village of Nyos in northern Cameroon when he spotted a dead antelope along the side of the road. As he pressed on, he found 2 dead rats, then a dead dog, then a whole host of other dead animals. At first, he thought they might have been killed in a freak lightning strike, but as he arrived in Nyos, he soon realized that whatever had killed these animals had extended its reach much farther than lightning could. Among the huts, there were dead bodies strewn everywhere, human bodies. Not a single person was left alive, but there was no sign of what had killed everyone. The doctor ran for his life. Over the next few days, it became clear that the people of Nyos and several other nearby villages had asphyxiated from breathing in carbon dioxide, but figuring out what caused this tragedy took much longer. And it would be more than 3 decades before villagers could be sure that the area was safe again. This is the story of the Lake Nyos disaster and the surprisingly low-tech method of preventing a similar tragedy from happening again. Located in Central Africa, Cameroon is a country with a bit of everything: desert, savanna, mountains, and tropical rainforest. As a result, it's often described as Africa in miniature. And among that varied landscape, it also has volcanoes. The so-called Cameroon line is a nearly straight line of volcanic rocks that scientists think formed when the entire continent of Africa rotated about 80 million years ago. For context, that's like 30 million years after Africa and South America had their major breakup. All that rotation failed to rip Africa itself apart, try as it might, but it did cause enough magma to spill forth and make a bunch of volcanoes. In the ocean, volcanoes along the Cameroon line formed several islands, including São Tomé and Príncipe. And on land, we got the Uku Volcanic Field, which extends for around 100 kilometers along Cameroon's northwestern border. Within this region, there are a bunch of big volcanoes, like Mount Uku, Mount Babanki, and Mount Nyos. And pretty much the whole landscape has been shaped by volcanic activity. In particular, there are more than 1,000 cinder cone volcanoes and around 50 volcanic lakes called maars, which have been blasted out of the bedrock by explosive eruptions. One of those maars is Lake Nyos, which is more than 200 meters deep and covers an area of around 1.5 square kilometers. Scientists think a volcanic eruption excavated the lake's crater in the granite bedrock about 12,000 years ago, and the water inside it is held back by a rim of material left behind by pyroclastic flows. But while things might have seemed quiet at the surface over the last few millennia, at the bottom of Lake Nyos, a disaster had been brewing. See, there's a network of hydrothermal cracks and vents which underlies the entire Uku volcanic field, and it turns out that one of those vents releases into the waters of Lake Nyos. Quietly, these so-called soda springs had been leaking carbon dioxide gas out of the lake bed. Now, normally that wouldn't be too much of a problem since the gas can dissolve in water, and the pressure of 200 meters of lake on top of it is enough to keep it in place at those low depths. But all that changed on the night of August 21st, 1986. Around 9:30 p.m., a giant cloud of carbon dioxide was suddenly expelled from the lake at up to 100 kilometers per hour. It filled the lake basin, extending 100 meters above the crater rim. But then, because carbon dioxide is heavier than air, that cloud spilled over the northern rim and surged down across the landscape. Traveling at up to 50 kilometers per hour and with a thickness of about 50 meters, the cloud of gas filled the valleys, flowing through the nearby villages of Nyos, Cha, and Subum. And everywhere this concentrated cloud of carbon dioxide touched, it brought death. Normally, CO2 makes up just a tiny fraction of the air we breathe, around 400 molecules in every million. But when that concentration rises, the human body can quickly become overwhelmed. We are constantly making carbon dioxide in our cells, but our circulation and respiratory systems work hard to get it out as soon as possible. In fact, when we hold our breath, the signals we get from our brain are responding to an increase in the amount of CO2 in the blood rather than a lack of oxygen. When the carbon dioxide levels outside of your body rise, you start experiencing some of the same symptoms, like a desperate need to breathe, called air hunger, a fast heart rate, and fast breathing. However, at high enough concentrations, the carbon dioxide levels in the air match the levels coming out of your body. There's no concentration gradient for the gas to diffuse out of your blood, meaning you can't get rid of it. According to the CDC, carbon dioxide is immediately dangerous to life and health when it hits 50,000 parts per million, or around 5% of the air you're breathing. That's more than 100 times its natural concentration. At this point, CO2 levels inside the body keep rising from both internal and external sources. Any gas dissolved in your body fluids increases their acidity, which has a profound impact on how critical body functions work. Enzymes and other proteins lose their shape, so they stop working. Blood cells can't carry oxygen as effectively. You start to feel fuzzy and lightheaded as your cellular machinery shuts down. Eventually, the neurons in your central nervous system stop firing, sending your body into unconsciousness, coma, and potentially death. This can happen in mere minutes when the concentration hits 10% of the air. And of course, if carbon dioxide is the main gas you're breathing in, then you're not going to be getting the oxygen your cells need to keep functioning. At Lake Nyos, experts estimated that around 1.2 cubic kilometers of carbon dioxide was released from the lake into a single cloud. That cloud would have started out at 100% CO2, and because of how fast it moved, it wouldn't have had much chance to mix with the surrounding air until it was very spread out. So the inhabitants of the surrounding villages would have had little warning, and no chance to avoid the invisible cloud of death that descended from the lake. In total, around 1,800 people were killed, along with roughly 8,000 livestock animals and uncounted numbers of wildlife. It took over a day for a rescue group to arrive, and nobody is sure of the precise death toll. People had already started burying the bodies in mass graves, and many survivors had simply fled the area, not knowing what had caused this tragedy that had killed their friends and family. It was clear that all those people had been killed by breathing in carbon dioxide, and experts were pretty sure it had something to do with the volcanic lake at the center of the disaster zone, but they couldn't agree on exactly how. 7 months after the tragedy, in March 1987, Cameroon's president hosted an international science conference for 100 experts from a range of disciplines to unravel the geological mechanism of CO2 release. And we'll get to the results of that unraveling right after this ad break.
This SciShow video is supported by Delete Me, the hands-free subscription service that removes your personal information from hundreds of data brokers and people search sites. It's set-it-and-forget-it peace of mind. When you sign up, you tell them what information you want gone, and their privacy experts get it gone, reducing your risk of phishing, doxing, swatting, and harassment. Delete Me is trusted by judges, journalists, and by me. They have removed tons of records for me. And by they, I mean real people available for custom requests and help when you need it. They use their own tech and don't outsource to third parties, so your data stays safe. Get 20% off Delete Me consumer plans when you go to joindeleteme.com/SciShow and use the promo code SciShow at checkout, or just use the QR code on screen.
At the end of the 5-day meeting, the scientists had basically settled into two camps. One which thought the carbon dioxide had come from a volcanic eruption beneath the lake, and another which blamed the gradual buildup and release of dissolved gas in the lake itself. The eruption hypothesis fits with what we know about how volcanoes work. Without warning, hot magma underground can superheat groundwater, causing it to flash into steam and explode upwards, carrying volcanic minerals and gases into the air without any lava. This is what's known as a phreatic eruption. Some survivors reported a sulfurous smell in the air at the time of the disaster, while others heard rumbling and saw a surge of water, both of which seemed to fit with a volcanic eruption. But on the other hand, there was no ground movement noticed by survivors or recorded by the nearest seismometer 200 kilometers away. Plus, later geochemical measurements found that there were none of the other volcanic minerals you'd expect to see left behind in the lake water. So instead, the other camp of experts was convinced the carbon dioxide had been gradually seeping into the lake and saturating the bottom layers with gas, until some external force triggered its release. At the lake's maximum depth of around 200 meters, water can hold up to 15 times its own volume of carbon dioxide, and it's been estimated that every liter of water in the lower parts of Lake Nyos contained between 1 and 5 liters of CO2. The weight of the water above this saturated layer would have acted like a cap on a soda bottle, keeping all of that carbon dioxide inside. But if the status quo is ever disturbed, if something displaces the gas-rich layer at the lake bottom, that layer rises up and suddenly experiences less pressure, like opening that soda bottle. The dissolved carbon dioxide starts to come out of solution and forms bubbles. Those bubbles rise turbulently, pulling in more gas-rich water and forming ever more bubbles, and so on and so on. So the final result is this huge outburst of carbon dioxide at the surface. All of that fits with these observations from Nyos as well. The rumbling and surging of water could have come from gas bubbling violently out of the lake's surface. Plus, the lake level had dropped by about a meter after the event, which could be explained by the loss of all that gas from the lake's bottom waters. Today, most scientists have come to agree that this is the most likely explanation for the Lake Nyos disaster. And it's not the only one. 2 years earlier, 37 people died from carbon dioxide expelled from another Mar lake, Lake Manoon, less than 100 kilometers away. The term limnic eruption, literally an eruption from a lake, was coined to describe these two carbon dioxide emission events. They are, however, the only limnic eruptions in history that scientists are aware of. What still remains unknown is what triggered the release of gas from Lake Nyos' bottom in the first place. It may have been a landslide, since a relatively recent scar was spotted at the edge of the lake during aerial surveys, but nobody knows exactly when it happened. Alternatively, it may have been an influx of water from a ton of recent rainfall. The evening of the disaster was reportedly a rainy one, and the cold, fresh water could have sunk to the bottom and disturbed the lake's lower layers. Or there could have been no external trigger at all. The bottom layers could have just become oversaturated, and any further carbon dioxide was forced to form bubbles despite the pressure. Without any certainty about causes or triggers, the surviving population around Lake Nyos were understandably cautious. 15,000 survivors fled the area, and over 4,000 villagers were resettled to temporary camps in the first week after the disaster. Eventually, they were relocated to permanent sites far away from the potentially deadly lake. But these villagers had lost their ancestral homes, along with prime agricultural and pastoral land that they depended on for their lives and livelihoods. So at that 1987 conference, a long-term solution was sought to ensure a disaster like this would never happen again. The solution turned out to be a bunch of flexible plastic pipes and a controlled recreation of the process that caused the eruption in the first place. It was nicknamed the Lake Nyos Organ Pipes Project and tested throughout the 90s. Permanent installations started in 2001. Essentially, the project featured long plastic pipes installed vertically into the waters of both Lake Nyos and Lake Manoon. Using a small pump, operators could trigger the creation of bubbles at the bottom of the pipe. These bubbles would expand and rise, pushing the gas-water mixture up the pipe and pulling more carbon dioxide-rich water into the bottom. This created a self-siphoning process that continued without any external input. Up at the surface, the gas and water was expelled from the pipe with such force that it created a continuously flowing jet, basically a fountain in the middle of the lake. When this permanent siphoning began, powered by high gas concentrations, the jet reached a height of 46 meters above Lake Nyos' surface. But over time, the gas concentration, and therefore the jet height, decreased until it was just a spray less than a meter high. So we had a clear visual indicator that at least some progress was being made, and measurements of the gas concentration at the bottom of the lake confirm the success of the degassing project. In 2001, water at the bottom of Lake Nyos started out containing 10 liters of carbon dioxide for every liter of water. That's worryingly close to the saturation point. But by 2018, this had been reduced to just 1.35 liters of CO2 per liter of water. Lake Nyos and Lake Manoon won't ever be carbon dioxide free. The volcanic gas leaking in from the Uku volcanic field will make sure of that. But now, the hazardous levels have been reduced, and the carbon dioxide levels can't rise higher because any excess will immediately be degassed through the permanent organ pipes. With just a few plastic pipes in each lake and a clever bit of physics, the threat of another limnic eruption has been eliminated. Most natural disasters are unexpected and uncontrollable, but just this once, it seems like scientists and engineers have triumphed over the Earth.